Welcome to our fourth discussion on section 2.3, evaluating limits algebraically. In this video, we're going to be doing a bunch of short limit practice problems. So the following questions are from worksheet 2, posted on B courses, question number 7, part A, B, C, D, and E. So the questions are here. I want to begin by giving you 7 minutes to try these. 4, 3, 2, 1. Pause the video. Give yourself 7 minutes to really try these questions. That may not be enough time to finish all of them, but hopefully to make some good progress on several of them. All right, so hopefully you pause the video and really try these for about 7 minutes. Let's start to talk about them together. So remember that when we're evaluating limits algebraically, the first thing that we want to do is plug in. So let's start with part A and plug in. X is approaching 3, and if we plug 3 in, on the top I get 6, on the bottom I get 1, and 6 over 1 is 6, and that's my answer. So if I plug in and there's no problem like getting an undefined thing, that's just going to be my answer. Alrighty, let's do part B, and let's start it off by plugging in as well. So if I plug in as my first step, this time I'm going to get 0 on the top, and 3 minus 2, which is 1 on the bottom still. And 0 divided by 1, that's just fine, that's 0. And that's a totally fine thing, and again, that's my answer. So A and B were both pretty quick. Let's do part C. So in C, let's start it off again by plugging in. And if I do that, this time on the numerator, I'm going to get 6. And on the denominator, I'm going to get 0. When we have a non-zero on the top and a 0 on the bottom, so for expressions of the form non-zero over 0, after you just straight up plug in the number, our strategy is to take one-sided limits. So we're going to take one-sided limits, and recall that when we do that, these will be infinity or negative infinity. All right, so let's evaluate those one-sided limits. Maybe let's start with the one from the right. So one thing that I'm going to comment on about these discussion videos is, because I'm giving you more time to try these problems, like in this problem I gave you about 7 minutes to try these, when I go through them, I will occasionally go at a faster pace than I ordinarily would in a lecture video, because I'll assume that you will have done some of the steps already. Okay, or at least thought through the problem a little bit. All right, so to evaluate the limit from the right, let's write it. We get the limit as x approaches 3. I put a little plus sign in the exponent of x plus 3 over x minus 3. So let's break down what's happening as x approaches 3 from the right. So if I form a number line to represent this, I'll put a tick mark at 3. And I'm approaching 3 from the right-hand side, which is this side. And on that side, x is bigger than 3. Okay, so I'm going to be a little bit more precise now when I plug in values here. There was no issue with just plugging in 3 straight up to the top, and that gives me 6. On the bottom, I'm actually plugging in something slightly bigger than 3, and that's going to make the denominator actually a little bit positive. It's going to be close to 0, but it's actually a little bit bigger than 0. So my notation for that is we write 0 with a little plus sign. So what is 6 divided by 0 with a little plus sign? Just as an example to get a feel for this. Let's say I had 6 divided by 0.0001. I could rewrite the denominator as a fraction to get 6 over, and this would be 1 over 1,0,0,0,0. And then when I divide by that fraction, 1 over 10,000, that's the same as multiplying by the reciprocal. So I get 6 times 10,000, which is 60,000. And that's a huge number. And if I made the denominator even smaller, when I reciprocal that, I would get an even huger number. So I know this is going to be some type of infinite thing. And the top is positive, the bottom is positive, which makes this positive infinity. So now we're ready for the limit from the left. So from the left, we will have the limit as x approaches 3 with a little negative sign here. X plus 3 over x minus 3. If I do the same thing and depict this with a number line, I'll draw 3. This time we're approaching 3 from the left-hand side. which means that we're a little bit smaller than 3. X is a little bit smaller than 3. So there's no issue with plugging in 3 to the top, which gives me 6. On the bottom, I'm plugging in something a little bit smaller than 3 in for the x, like 2.999 something, a little bit smaller. And that's making the denominator close to 0, but a little bit less than 0, so a little negative. So again, when I divide the 6 by something super, super small, it's going to make the whole thing huge, an infinite type thing. But this time, the top is positive, the bottom is negative, which is going to make this whole thing negative, negative infinity. So then my conclusion is, these one-sided limits are different, since the one-sided limits are different. One-sided limits, let me abbreviate, limbs, are different. That means our limit, the limit as x approaches 3 of x plus 3 over x minus 3, that does not exist, or D and E. And that is our answer. Let's do part D. This was the limit as x approaches 3 of x squared minus 6x plus 9 over x squared minus 9. Again, let's start it off by plugging in. And if I do that, the top and the bottom are both going to be 0. And this is an example of an indeterminate form. And we handle these by simplifying. We will simplify these. If you've taken calculus before, you may have learned about something called L'Hopital's rule, which you can do on indeterminate forms. For our purposes, I don't want you to use that yet. We may not use L'Hopital's rule. If you've never heard about that before, that's totally fine. We'll learn about that later in our class. You may not use this rule until we get to section 4.4. Right now, I want us to handle these in the way that we've learned, which is through simplification. All right, so let's simplify. We get the limit as x approaches 3. The top factors is x minus 3 squared. The bottom is a difference of squares. So that's x minus 3 times x plus 3. And now there's a little bit of cancellation, which is nice. Limit as x approaches 3. And I get x minus 3 is left on the top, and x plus 3 is left on the bottom. All right, so continuing this at the top of the page now. Often when we have these indeterminate forms, we try to simplify it till we get some sort of cancellation happening. And now we are going to try to plug in again. We plug in again. And when we do that, plugging in 3, we get 0 on the top, and we get 6 on the bottom, and 0 over 6 is 0. And that is my answer. So finally, let's do part E. Started off by plugging in. In fact, this is just the last problem, but the fraction is flipped. So when I plug in, I still get 0 on the top and 0 on the bottom, which means indeterminate form, I gotta simplify this. Got to simplify it. And at this point, we know how the top and the bottom factor, because we did it in the last problem. It's just flipped. So the top is now x minus 3 times x plus 3, the difference of squares. The bottom is x minus 3 squared. Now I'll do the cancellation, so that we get the limit as x approaches 3 of x plus 3 on the top, x minus 3 on the bottom. And at this point, we have the same problem that we saw in part C. Part C was the limit as x approaches 3 of x plus 3 over x minus 3. And remember there, we plugged in, we got a non-zero over a 0. We did one-sided limits. One of them was positive infinity, one of them was negative infinity. So because those were different, the limit did not exist. So we can just say, because we've done that work already, this D and E, this does not exist. Does not exist from part C.